Good morning to everyone. Welcome to the first session, Decoherence in Quantum Physics and the Parallel in Buddhist Philosophy. Before I proceed the session, I politely request everyone present here to kindly switch your mobile phones to the silent mode to avoid the interruption. Thank you. For this session, I would like to invite on the dais Professor Usha Devi ji, Dr. Ravi Prakash ji, Mr. Pranshu Samdarshi ji, and Professor Karam Tej Singh ji Sarao, who shall preside over the session as the chairperson. Professor Karam Tej Singh ji Sarao did his PhD in Buddhist philosophy from Delhi University. He was awarded the prestigious Commonwealth Scholarship in 1985 to study at the University of Cambridge, from where he received his second PhD in archaeology in 1989. In 1993, he joined the Department of Buddhist Studies, Delhi University, as the reader, where in 1995 he was selected to occupy a professorial chair. And he has written 16 books and published more than 250 research papers and articles. And over to you, Professor Karam Tej Singh.
Thank you very much. I'm really grateful to Geshila Ramdulji for inviting me to chair this session. Honestly, I heard about the word quantum only a few years ago. My knowledge of quantum physics is almost zero. And so I have come more as a learner here than as someone who could contribute to this conference otherwise. So without wasting any time, I would like to invite the first speaker of today's session, Professor Usha Devi ji. She will present her paper on decoherence in quantum physics. Professor Usha Devi ji has been teaching in the Department of Physics, Bangalore University for around 20 years. She is an MSc gold medalist, and she had won the Indian Physics Society Young Physicist Award during the year 1997. During 2008, she was awarded the Commonwealth Scholarship and worked with the research group of Professor Sandhu Popescu at Bristol University, Bristol. Dr. Usha Devi has published more than 50 research papers in reputed international journals and serves as a referee of international and national journals. So may I invite Professor Usha Devi to make a presentation, please.
Good morning, everybody, and thanks the organizers for inviting me and also for initiating such a what is called different topics and to organize a conclusive way of interactions in possibly in a deterministic way. So let me begin with this. I am from Bangalore University. I will just stick to what is decoherence, what we know in quantum physics, and I have avoided So I would just start with how quantum theory was so quickly developed, and it was in 1925, Heisenberg's matrix mechanics, that is from numbers we shift to what are strange quantities called matrices to perception of physicists in this particular area, that is observables or matrices was something new. And Dirac's symbolic quantum theory was in 1925 autumn winter, Schrodinger's wave mechanics in 1926 winter, and basically in the work of Heisenberg and Dirac, the emphasis was on the dynamics of physical observables. That's I'm trying to say how they developed from their own viewpoint. So it was in the dynamics of physical observables, which were later identified to be non-commuting. Professor Mukunda mentioned about it, how our shift from numbers to matrices comes. And in Schrodinger's work, it was description of a state of a system, which is though not realizable in actual experiments, but this was the kind of crux of the story. It carries everything. So when Schrödinger formulated the description of state, Dirac could recognize that there is something called a superposition possible because of the structure of the Hilbert space or the mathematical base from where this quantum theory is being developed. So this is basically I have picked from a resonance article. This was very clearly talks about these developments, and superpositions as a concept and in quantum theory as a mathematical theory is fine. But then we ask a question, is it possible for me to think about macroscopic superpositions? Superposition is, that is basically quantum mechanics is tested through controlled experiments and it is accepted as a correct theory. But there are no examples of any conflict between what is controlled observation, what is observed controlled in a controlled way. Yet, well over 85 years of its inception, the debate about the relation of quantum mechanics to the familiar physical world that continues. So now, superposition is something like a particle can be found in two different positions at the same time. This is something unfamiliar. And a two-level atom, that is what is a physicist would consider as a simple example. You have a ground state and an excited state. In between there is nothing in quantum theory. So then, if you can have a particle atom in a ground state or in an excited state, but quantum theory gives you a mathematical formulation which says it can exist both in ground state and excited state. And how do I see it? I can probe it through an electromagnetic field. An electromagnetic field of photons interact with the atom. I would see what are called as Rabi oscillations. And these oscillations they will tell me how this is in a superposition state. But then the question is, in real situations, you never have atoms in isolated way. Even the process of observation would be killing the state. So what is done is, superposition fades off after a while. So Rabi oscillations would disappear. Initially, atom can be in a superposition, but as time progresses, it is found in only one state at a time, randomly chosen. That's realized. And what is decoherence time? So time taken for the superposition, which is unfamiliar in classical physics, that is particle cannot exist in two different states together. So this time taken for superposition to disappear becomes important. That is it something very long or is it something short that I can perceive it, etc. So now, as we said, this language is precise, quantum language. So I do a controlled experiment, and what I said so far is to say, we have what is the time at which I probe where is the atom. And there are oscillations. Those oscillations are basically the Rabi oscillations. And this is when I have no decoherence. That is, then there is a continuous oscillations. But then when you go ahead, you will find if there is a noisy system, that is, it's not isolated, there are collisions with other atoms and interactions with the electromagnetic field itself, which is used to probe it, there is an interaction. and this particular oscillations would decay. So that's how we talk about it. When I said macroscopic superposition, famous example is that of a Schrodinger's cat. So we have cat alive or cat dead. Is there cat alive is one state which we can clearly say. Cat dead is another state which we can clearly say. Macroscopically, is it possible to have two states existing at the same time? This is against our perception. So people gave this kind of thought experiments to say that quantum mechanics, do we have such superpositions possible? Is quantum physics the language of the world? Can I explain it using that even at macroscopic level? Was the kind of idea. And then quantum decoherence would tell you that either what you see as alive cat or what you see as dead cat would emerge. So that's what is the decoherence. That is, it's always, you can't treat the state of a cat in quantum physics to be isolated. There is always an interaction, and you would find that it is either dead or alive. So the decoherence is thought of as a transition from quantum to classical. So one says in quantum theory, the kind of states that are possible is infinite. In the sense, not to be precise, Hilbert space is huge. All states are allowed. Superposition is possible. But classical states is a small subset of such possibilities. So Einstein had written in a letter to Max Born, who was also a founder in quantum physics, he talked about the interpretation of the wave function. Mod squared of the wave function, if you compute mod squared as a mathematical quantity, that gives you the probability of finding a particle in quantum physics. So he had written saying that if I have two solutions to the Schrodinger equation mathematically, then when the system is a macro system and when phi1 and phi2 are narrow, that's a word, but narrow means I can find two with some amount of dispersion, I can identify it. Sorry. So then with narrow with respect to the macro coordinates, then by far the largest number of cases, this is no longer true that we find superposition, is what he writes. Narrowness with respect to macro coordinates is not only independent of the principles of quantum mechanics, but moreover, it is incompatible with the principles of quantum mechanics. That is, he is showing his unhappiness with quantum mechanics in a sense. We don't see it in macro world, that is the superpositions, is what he says. So then the question is, how does one explain the origin of a classical world emerging from a quantum substrate? So if quantum physics is the ultimate and everything in nature can be explained using quantum physics, then how would a classical world emerge from it is also a part of the theory that I need to explain. How would classical physics emerge? For that there are a lot of efforts. And how do we find classical states? That is what Einstein calls as narrow, localized with respect to macro coordinates. So this is to say that decoherence as observed in quantum physics is classicality is an emergent property. Quantum physics explains things and then classicality emerges is what is observed. And quantum suppression, decoherence means dynamical suppression of quantum superpositions. One would try to explain like that. It is induced by continuous monitoring by the environment. There is always an environment which is seeing a quantum system, and what we find because of such observation, we have decoherence setting. That is, we don't find quantum features like superpositions. So a record of the footsteps of the system gets imprinted in the environment. I am saying it in different words. So because of the system environment evolution, it is only to say evolution of a system alone. If you look at only that, that's not what is seen in nature. One has to have a system environment evolution and watch the system. So then what happens is what we see in nature. So most quantum states of the system during system environment evolution are unstable. This is not a precise word, but they don't stay. In the run of the evolution, you will find a preferred set of states eventually. Joint system environment dynamics selects some preferred states called pointer states by Zurek, that is who had invented it. I might say something about it. So classicality is induced or enforced on the system is what we see, which is being observed due to its interaction. I am repeating the same thing in different words. So decoherence helps us to understand the origin of the classical world from quantum scenario. So now the classical limit is used as a word saying that explain how the classical realm emerges from the quantum domain. There are several approaches for it. For example, large quantum numbers will give you classical physics was one of the things, but this is a dynamical approach. During dynamics, you have classical features. So classical limit is explained with the help of a dynamical process here. That is a separate thing in addition to various approaches to understand how classicality emerges from quantum theory. So this is a cartoon to say there is a gate and then there is a person asking, do you have a classical apparatus first? Then only you are entered within this world. This is from Zurek's paper. So now let me just say how one does it in a mathematical way without equations. So Schrödinger equation is a unitary evolution. So if it is non-unitary, decoherence is modeled mathematically as a non-unitary process by which the system couples with its environment. That is, there is in a sense, precise way of dealing with the decoherence in terms of equations of mathematical equations. That is how one identifies. And a feature of non-unitary dynamics is something which is explored. So systems dynamics becomes irreversible. If it is unitary, it would have been reversible. These are some features which are clearly understood. Unitary dynamics is reversible, but non-unitary dynamics, one cannot say it is reversible. So it is an irreversible process. Once it reaches the classicality, you don't see any quantum superposition there, kind of a thing. So one refers to the decay, it is another way of saying, and again using different languages to mention the same. It is decay of what is called as quantum information. The information that we know is quantum in a superposed state. Decay of quantum information caused by coupling the system to the environment. Decoherence refers in general to the process by which information of a quantum system gets modified by the system's interaction. These are, again, I am saying different ways in which people would have used it, but it all means as a consequence of non-unitary evolution, how would one interpret what is decoherence? So during the evolution, the system and environment get entangled in general. That can be seen through the mathematics. And a description of the system by itself cannot be made without also referring to the state of the environment. That is, we know precisely about the whole, but we are looking at what is a part of it. A part cannot determine the whole is the kind of thing in quantum physics. So this entanglement is something that I am just trying to show, that you have both the things there, and state of the system can be written as one of them is in zero state, one of them is in state 1, sorry, there is a typo, it's a 1A, 1E. So 0A, 0E, for mathematics wise, I will say that one of them is in zero, system is in the zero, environment is also in zero. That's the entanglement that one sees when a system interacts with the environment. Because of this, if I see the environment, it means where is the system. So it will either be in zero or in one, not in both, because of the interaction, is what is interpreted. So one talks about qubit, that is, a bit is a classical notion, language-wise. You have 0 or 1 used for communication. So if you say a Q bit, quantum bit, it can exist both in 0 and 1, fine. But when it interacts with nature, that thing will go away. So the question for quantum information is how to retain that superposition and do some operations on quantum superposition, superposed states. So it is again just to make it a cartoon to say, decoherence helps us to understand the origin of classical world. That's how we thought about what is classical emerging from quantum. That's a fundamental question. But then also quantum information people and everybody else would like to know, it's an enemy of quantum information processing. I want to retain quantum nature. Then how is it possible for me to do it? So there are experimental efforts which will try to keep it. If it is, say for example, 10 to the minus 20 seconds is the decoherence time, it's very big. So can I reduce it by some way, and so that I can hold the superposition under control. So these are experimental efforts which are being reported recently. So when you say observation, I said decoherence is an interaction, results because of an interaction between system and environment. And the interaction itself is like a process that environment sees the system, it observes the system continuously. When it observes the system continuously, it is a measurement basically. I see it. A quantum system is seeing another quantum system. One is macroscopic, one is microscopic, let us say. So then a macroscopic system viewing a small system, microscopic system, this is observation. Then how does one explain measurement in quantum theory becomes important. So quantum measurements is a difficult situation, that is how to explain it within using the language of quantum physics is a problem. So there is a foundational debate on how to explain quantum measurements within the quantum formalism. So I should use only that language to explain it. So, and how do we have macroscopic apparatus to be described using quantum physics? I have to explain everything in quantum physics. So now I just try to say that time evolution in quantum physics is, for an isolated system, it is the Schrödinger equation. In terms of what is called as a density matrix, which is written in some simple way, this one sees as a deterministic unitary evolution in the language of quantum physics. So, but then you have non-unitary evolution, which was given by a few people. Okay, 2 minutes, all right. So you have very few, that is in 1976 it was discussed that there is a non-unitary evolution and there is a irreversible kind of a dynamics coming from what is called as a Markov master equation. So now this master equation is used to explain decoherence in some particular examples which is very clear. This example tells us what is the evolution, what is the unitary evolution part, and what is called as a relaxation. That is, if I keep a cup of coffee, it will get cold and I will only get a cold coffee is a relaxation. But I will see what is decoherence, that is, there is a superposition being split. Can I discriminate between the two time scales? That is, before I see coffee being cold, the superposition dies, that's very quick. So I won't even see superpositions in my day-to-day life, is what is seen. That is, quantum is hidden in under its layers, but it can't be seen is what is being said. And it is an example where I keep temperatures to be, let us say, room temperature, and mass is 1 gram per particle, and then I have separation of 1 centimeter, keep it at 1 centimeter. Then the ratio of time scales, that is decoherence time as versus relaxation time, what we see is something like 10 to the minus 40. That is, it is relaxation. Even if the relaxation rate is that of age of universe, relaxation is slow, let us say, it is going to be 10 to the minus 23 seconds. That's through some particular examples. We can't still say conclusively what is invariant under this. So that approach is there. I will just mention it and then go ahead. These are some papers, but I will just say how one monitors the environment. There are methods to monitor the environment today. If I say after Schrodinger Must equation, people have explored, can I dig through this Must equation and find something stochastic about the dynamics? That is what is happening inside. That is fine-grained kind of observation. And people find that you have some nonlinear extensions of Schrodinger equations. They are called stochastic Schrodinger equations. So that is, if I modify it without bringing, that is for a system and interacting with the environment, I do have, there are people who discussed about it, Weinberg and these people were required, they wanted to say everything should be formulated starting from quantum theory. I don't have a unitary evolution, but I have a non-unitary evolution for a system, and average it, you will get what is called as a master equation. If you look at such equations, you will find nonlinear equation and think of quantum state fluctuating as a Brownian motion. That is, we do see Brownian motion, but state fluctuating is the trajectory which is recorded in experiments now. And asymptotic limit, that is, as time grows, what happens there is what is important. So I will just stop it. This is called stochastic unraveling, and this explains what is called as collapse, is the hope. That is, one has some particular controlled mathematical ways of looking at it, and one says state collapses at the end, and one can talk about it in a clear way, as this is the emergent phenomena. This is like, even if you start from somewhere, all the stochastic trajectories would end in one clear eigenstate, what we call, and this has been explored for quite some time. So I will stop here. This is to talk about system-environment interaction leading to suppression of quantum effects, and one tries to bring that back and retain it. That is present technology, hoping to develop it. And then the measurement is another problem. Decoherence couldn't properly explain it. So one tries to explain it using what are nonlinear Schrodinger equations and bring in what is decoherence, what is measurement problem, everything under one umbrella. So I will stop it here. Thank you.
Thank you very much, ma'am, for a very interesting paper. We will have about 20 minutes at the end for question answers. So if you have any questions or observations to make, we'll have 20 minutes after the speakers make their presentations. The next speaker is Professor Prakash. He is a psychiatrist, neurophysiologist, and a freelance researcher conducting research in quantum epistemology and consciousness. After completing his bachelor's degree in medicine, he did his diploma in psychological medicine from the reputed Central Institute of Psychiatry, Ranchi, followed by MD in physiology from Ramaiah Medical College. His interest in consciousness has led to publication of several papers and books on the topics of near-death experiences, yogic state quantum epistemology, and neurocognition in quantum theories of consciousness. Having over 120 publications, he is also the author of some research journals. Professor Ravi Prakash shall read his paper on decoherence and cognition. May I invite you?
Yes, thank you so much. Thank you. Before starting, first I would like to thank the organizers, the Tibet House representatives, and Dr. Kishi Roy, not only for inviting me, but actually for organizing this conference. This was the need of the moment, and I have been always telling that this kind of interface that is created between different fields, it is the need of the moment right now, because maybe the information or the idea of reality, it may not be unidimensional, there may be different dimensions involved. So before starting, I would like to tell how I got into this. I'm basically a psychiatrist. I see patients. I'm practicing right now in Bangalore. How did I get into quantum physics means? In psychiatry, basically, there are a lot of conditions which are complicated by the presence of consciousness. You know, persistent vegetative states, dissociative conditions. All these conditions, they have a inbuilt problem that we are not able to understand, that why a person will go into a persistent vegetative state. He is not alive, he is not dead. What happens in the coma? When will he come out of the coma? We don't know. What is dissociative state? We do not know. So as I started seeing, I started observing a fundamental problem, a basic problem in the concept of psychiatry. That was the lack of understanding of consciousness. Some people would say it's a field of psychology, so I tried psychology and I found that they don't have answers. I came to psychiatry, they don't have answers. I tried to go to different fields, they did not have answers. So then I understand perhaps it is not one unitary thing, perhaps it's an interface of many different things. That is how I slowly, drifted towards the basic sciences of the human body. I did physiology, then I started working in quantum physics more from an epistemological and theoretical background. So first of all, I would like to apologize if there is a mistake from the perspective of mathematical formalism. I don't know the mathematics of quantum physics, and I'm going to take lessons from Dr. Shishir Roy later on. So I do not know. I do not know what's a bracket notation. I do not know what are operators. I do not know how the density matrix it progresses. But there is a basic understandability in quantum mechanics that really excites me. And I would just like to the topic that has been given to me. I'll try to stick to that. The decoherence and cognition. Actually, it's a very tricky topic to start. First of all, I'll just introduce. I'll address the measurement problem first of all, followed by the role of consciousness in wave function collapse. Attention. Basically, this presentation will be about one cognitive function, that is attention, basically, which is the basic of all the other cognitive functions. Attention is the basic of all the other cognitive functions that we have. And how the emergence or how the presence of attention, it complicates all of the issue. Now, this is very important because my job is here to just increase your problems here. Because the attention is something which has not been addressed by any field as of now. And when I published my first paper on the topic of how divided attention or sustained attention or selective attention, it complicates the concept of decoherence or wave function collapse. It was well received, but it was not properly understood, and still there are a lot of controversy. I keep receiving mails that how is it possible. So it needs more, discussion. Okay. Now I will start with the difference in the terminologies. Actually, there is a problem in the terminology. First of all, I would say when I started working on the idea of quantum mechanics around 10-12 years back, at that time the concept of wave function collapse was very prominent. Everyone was talking about wave function collapse. If you know about the orchestrated objective reduction, a theory given by Dr. Roger Penrose and Stuart Hameroff, they have worked exclusively on the reduction, the collapse of a wave superposition, wave function or superposition that we have in the brain. And slowly as time passed by, and in the past 10 years, I have seen that there is a shift from wave function collapse to decoherence. Now, earlier it was used all synonymously, decoherence, reduction, collapse, everything was used synonymously. But now, more and more quantum fields are trying to make it more applicable. That means to say more experimental in nature. For that, decoherence perfectly explains everything. And I am very happy that at least the idea of decoherence is being separated from wave function collapse. But I do not agree with the idea that wave function collapse should be given up. The reason is that it is the basis. As I will proceed further, I will mention that how it is one of the most basic crux of the quantum physics, and we should not just give up the idea. Okay, so decoherence, it's basically decoherence, it just signifies, I'll try to make things faster here. Decoherence, it just signifies the interaction, the passage of the information of a quantum state to the measuring apparatus and the vice versa. So there is a sort of entanglement because of which the information is passed from one state to the measuring of the apparatus and the vice versa. Whereas wave function collapse is a very specific thing where the process of measurement is done. Now the process of measurement is not very important in the plain decoherence ideas. That is something that we have to understand. But wave function collapse, when we say, that means to say a measurement is being done, and because of the virtue of measurement, the superposition of the states of quantum entity it is lost, and there is one state available, that is the collapse state of the wave particle superposition, you can say. Here there is a role of consciousness in the wave function collapse, and measurement problem is very important. Here, my presentation is in this direction, where I feel that the measurement problem is important, and I feel that consciousness is really very important when we are talking about quantum physics, because of some very specific experiments that have actually come up. Okay, I'll come to the measurement problem. One of the central themes of quantum mechanics, wide range of arguments regarding this. what exactly is measuring, who is the observer, what is being measured, how it is being measured, what exactly happens, is there a progression, is there a density matrix. There are a lot of arguments behind that. Decoherence idea, it does not consider wave function collapse as very significant, whereas the wave function collapse theorists, they consider that the measurement problem is very significant. Okay, now I'll come directly to the who is the idea of the observer. Who exactly is the observer? Different people, if you see into the writings, I would say that it's more not like so much presented in the papers, in the books especially that they have written. They have mentioned the idea of consciousness knowingly or unknowingly in whatever they have, they have tried to say. So some people say it's a mental act, some people will say abstract self, some people will say solipsism, introspective power. Consciousness was the first, the word consciousness was first used as specific to quantum mechanical collapse by Dr. Wigner in 1967, and he basically wanted to represent a state vector reduction, that is the quantum function collapse that we are talking about, but it started in 1967. Before that, the idea of consciousness was not so much entertained, although here and there it was there, but the measurement being done by a conscious entity, it was very much in the background of what they were writing. Okay, coming to wave function collapse. What do we mean by wave function collapse? So the formalism of quantum theory allows to write any given state as a superposition, as just ma'am said, of other states. So one state, one quantum state is a superposition of other quantum states, and in particular of such states where the observable of interest has well-defined values. Now these values, when I say, it may not be exactly mathematical values, it may be just a representation by quantum formalism or mathematical quantum formalism, as ma'am was trying to elaborate, but unfortunately the time is less. I'll just skip through it faster. Collapse of the state reduction means that the survival after the measurement word is very important, of only that state out of the superposition for which the value of the observable matches the result of the measurement. So here you have an expectation. You have a expectation of the result, and when what matches to the expectation, that becomes the outcome of the measurement. Okay. Now, coming to the central theme of this present conference, I would say, does consciousness have any role in the wave function collapse? Okay, Wigner, as I mentioned earlier, advocated the central role of consciousness. Recently, some experiments have also come. Double slit experiment is the double slit idea of the double slit experiment is been experimented many a times. And recently, Radin et al., they have, I think, conducted 4 experiments, 2 in 2012, 2 in 2013. And they found that when actually consciousness was involved, okay, the photon was, I cannot go into detail, the photon was measured by the retina, that is to mean to say the eye, and the outcome changed as soon as there was a conscious entity observing the double slit experiment related outcome. Okay, but the details we will not go here. But my idea, why I want to present, is that I say that it is not only consciousness which is causing the wave function collapse, or which is causing the trouble that we are experiencing. Okay, so there was a very good study published in Nature in 2006, Koch and Hepp. They challenged the idea that consciousness carries all of the burden of measurement with a strategic thought experiment. So what they did is that they demonstrated that if 2 different images are presented to 2 different eyes, okay, and one of the image is presented continuously, the observation of the other eye image, it is reduced markedly. That means to say, the attention that you are paying at that point of time, it somehow is not able to capture both the eyes, although both the eyes are supposed to be the elements of the same person's consciousness. Okay, the same argument they gave for Schrodinger's cat also. That means to say, if you give continuous image, then the observation by the other eye for the Schrodinger's cat, whether in the superposition he is alive or dead, it may not be always visible or always observable for you. But the reason is not consciousness here. The reason is that in addition to consciousness, there is another cognitive entity called as attention. Now, historically, attention has been, I'm not going through this what I'm presenting, so I'm just saying, historically attention has been confused with consciousness many a times. And now, as the time is passing by, we are recognizing that not only not only the cognitive states, but also the neurological underpinnings of the attention and consciousness are different. So they are both not the same things, and they are very two different processes that may be occurring in the brain, maybe outside, we do not know, but they are very different in nature. Okay, what is attention means? Attention, as in the previous slide you will be saying, there are 6 different components of that, and as we are studying more different components are coming up. But it can be said that attention is an orienting response for consciousness. So it is something that manipulates, or it uses the stream of consciousness to focus somewhere. And this, when I say, I am talking about one form of specific attention, which we can say as the selective attention. Okay, so you see all of scene, but your focus is one way. Your eye, I'm not talking about the eye, your eye is seeing everything, but your attention is focused on one specific thing. That specific thing can be regulated by top-down attention modulation or bottom-up attentional modulation. And that one single thing will become the selective component of the awareness, consciousness at that point of time. That is why it becomes very important, and especially when I talk about the divided attention, it will become even more important. So, attention plays a crucial role in orienting the response of the consciousness or regulating the consciousness overall, you can say. Okay. Later on, several studies came up. Some studies have clearly demonstrated now that attention and consciousness may not be always interrelated, and actually they may be counterproductive also for each other at some instances. These are specific cognitive studies, so I'll not go into the details of the cognitive mechanism, how they did this study. But now it is almost clear that attention and consciousness, they can exist at different points and they can work differently at the same point of time. Coming to the main question, why this distinction of attention and consciousness is important in quantum mechanics. Okay, I'll refer to the again. I'll refer to the previous study that I mentioned again, Koch and Stapp in 2006, where they found that in the same conscious person, if you are able to divert the attention, the outcome of the observation is different for both the eyes. Okay, so here what is different is attention actually. Here we are using something called as divided attention. Okay, and this divided attention is what I want to highlight by present study. Now I'll just go there. See, this is the usual assumption that we have in quantum physics right now. Okay, there is a measuring apparatus, there is a quantum entity, and the consciousness is observing that. Okay, but this is not what really happens. What really happens is that there is a quantum entity, a measuring apparatus, information is passing through the measuring apparatus, and then selective attention is there. And through the selective attention, it is going to the consciousness. So the selective attention plays here a very important role. And why it is very important is that here, the interface between the classical and quantum world, which is quantum or classical interface, which is called, which many people call it as the Heisenberg's cut, it becomes very important because the different concepts of where exactly do we say that a system gets converted from a quantum state to a classical state, it is not known, it is arguable, I agree. But here, when there is a additional variable of selective attention, basically there are two interfaces. Okay, the first thing is that in the classical quantum physics experiments or the wave function collapse or reduction that is caused by awareness, we are talking about an interface only between the consciousness and the quantum entity. But here, and in the change of the formalism where it is happening, that we do not know as of now, but the earliest interpretation by Bohr, it said that the measuring apparatus, somewhere it happens. The quantum distinction between the quantum world and the classical world, it happens inside the measuring apparatus. Okay, but Heisenberg's views were a little different. He said that it may not be a specific physical entity, just a change of formalism. That also he was pointing towards the measuring apparatus only. But here, in our view, we want to say that there is another interface, that is the attention and consciousness interface. Okay, the interface that is here. that is between the selective attention and the consciousness here. Okay, so the problem is that because the attention itself is very much regulated by the brain, similar areas are also involved in the consciousness regulation. So we do not know where exactly that interface is falling, the interface between the quantum world and the classical world. But it has to be somewhere inside the brain only, and therefore the whole process of measurement becomes very important. We cannot just brush it under the carpet saying that no, consciousness does not play a role. Consciousness does play a role, but perhaps because it is somewhere in the brain, in the maybe not a classical quantum state that we are talking about in the Hilbert space concept, which is at the Planck's level, but somewhere in the brain. And this we cannot just remove it. And this is becoming more and more discussed as my papers are being quoted more. So this is very important that we have to understand this additional interface of other cognitive functions in addition to consciousness. Okay, now I'll come to the important point, the divided attention. Okay. Divided attention actually we are using in our everyday task. You are able to drive a car listening to a music. You are able to drive a car and one part of your attention is controlling all the mechanics of the car and one part is looking outside. So this attention, your attention is already divided into 2-3 domains already. And it is specifically more important in more critical tasks like flying an aircraft. Okay, so the person has to have at the same point of time multiple inputs from different domains of his awareness. So he should be able to divide the attention between those different modalities. Now it is very baffling. Why it is baffling? Because it challenges the very unitary nature of the consciousness. Here we have been talking about consciousness is one specific unitary state which causes a wave function collapse, but it may not be the case. Consciousness itself may be surrounded or intertwined or regulated by many different cognitive modalities, including the attention. Okay, one important thing about the divided attention is that the attention can be divided intramodally or intermodally also. So when you give the divided attention task by something called as dichotic listening task, then the problem is different. But when you split it between a visual stimulus and an auditory stimulus by the n-back game, then the thing is very different. Then the outcome is really very different because here different parts of the brain lobes are involved. Okay, so these are the types of divided attention, but these are not the only types. These are the common types, intermodal and intramodal, that we use for cognitive tasks. But actually, such similar to this, there are many different forms of divided attention tasks that we can use later on. Okay, now I refer back to the experiment of Koch and Hebb. What exactly happens when two stimuli are attended simultaneously by a conscious brain? Okay, this is a very important question to ponder. We are talking about two different quantum states being perceived by the brain at one single point of time, which may not be practically very simple because there will always be a time lag between two stimuli that are being presented. But suppose for the theoretical sake, I know. Yeah, that is why I was having it up. So for theoretical sake, suppose we say that this is possible, then how do we explain that? For that, we have given two models. One is double quantum reduction model. That means to say, basically what happens is that there are two different quantum reductions happening in the brain, okay, when the stimuli is being observed at two different points of time. The problem is that in spite of the stimulus being presented very close to each other in the time, still there is a lag. So there are two different quantum state collapse that is happening in the brain. That is one model. The second model is that there is a single quantum collapse that is happening, which is basically the outcome of two different quantum superpositions that are being produced in the brain by two different stimuli. So in this view, what we suggest is that there are two different superpositions which happen before the main collapse, and that happens in the brain. Okay, there are other important things that I will not come. These are the drawings of a person with hemispatial neglect. So what will happen if the brain is conscious but you are presenting the stimulus on the other half of the visual field? Okay, how do we explain that? That's a very important question. Okay, now I'll come directly to the point. Why Buddhism and such meditative states are important here means, in meditative states, I have conducted research on all the three different states what I have mentioned here. Near-death experience is recently published in Annals of Neurosciences. Meditative states I have been studying from past 6-7 years now, and we have published several papers where the people are able to explain that in the core state of meditation they can have two different experiences. One is a core experience of the consciousness, which is a central blissful experience, and the other is outer experience of the emotions. Okay, now how do we explain that? It may look very simple or very silly in the from the outside, but actually it's a very complicated state. And this is not something that we have got in 1-2 people. It is like 100 of people we have studied, and we have seen that there is a state called as inner light perception. Now the inner light perception is not external light. They are experiencing some luminance or some light inside them, and this is very important. We cannot just ignore it. Why? How can we explain such an experience in a meditative state where the eyes are closed? Where is the observation? Who is the observer here? Where is the quantum reduction that is happening? Or is it a quantum phenomenon? We do not know. Okay, so lastly I wanted to talk a little bit about many minds view. There are many words views and many minds view. These are two different basically but evolved from the same concept. We are trying to right now study more about the many minds view, which can be one of the quantum mechanical explanation for the reduction process that we see in the divided attention tasks. Okay, now there are many minds view I wanted to talk, but this is what I'm expecting to explore further. There is a many worlds view. Many worlds view, it sounds ridiculous actually. So when you have two different superposition, your whole world divides into two different worlds, or multiple superposition, all the world divides into multiple worlds. Rather than that, what seems more logical is that the mind divides into many different superpositions of mind. If mind can be considered as a quantum entity, that's also an important question. Maybe it's not. Maybe it's just a theoretical imagination that I'm having. But it is something definitely worth exploring a little bit. Okay, with that, I end my presentation. Okay.
Thank you, Dr. Gulmohar. The third speaker is Mr. Sandarshi, who has been studying Buddhism for over a decade. His research concerns the history and literature of Buddhism in South Asia and Tibet. While doing PhD from the Department of History, Delhi University, Mr. Sandarshi has explored the dynamic relationship between the sacred feminine imagery and Buddhist culture. He has been the recipient of the Senior Research Fellowship of the University Transmission of India. Mr. Sandarshi will be reading his paper on the decoherence from Buddhist perspective. May I invite him to read his paper?
Thank you, Professor Sarao. I have been a student of Professor Sarao. I have been trained under him, and it's my privilege, and I feel honored and humbled to stand and present whatever little I have explored. So, we just had two very intense papers from Professor Usha Devi and Dr. Ravi. So basically, the approach of science as well as Buddhism. So here is a quote from this was in 1937, and Albert Einstein is saying, behind the tireless efforts of the investigator, there lurks a stronger, more mysterious drive. It is existence and reality that one wishes to comprehend. So the reality, all the what quantum physicists are trying to explore, or Buddhist philosopher, or any philosopher, they all are trying to explore the reality. Now, from 1934, if you look at this quote, this is from Stephen Hawking. He says, I don't demand a theory that corresponds to reality, because I don't know what it is. So from this 1934 to this was published in this book, The Nature of Space and Time, in 1996. Now, why Stephen Hawking has given up the exploration about reality? We just saw in Professor Usha Devi's paper, there are several inconsistencies within the theory of quantum physics, and there are innumerable theories. And none till date we don't have any perfect explanation of the reality. So at present, majority of scientists, they have given up this to explore the nature of reality. So, and there is a stark contrast between the approach of science and the approach of religion, or Buddhism, I would say. Here the goal of science is to explore the reality, to exploit it for the benefit of humanity and sometimes for the destruction also. But the approach of Buddhism or religion is something unique. It's about soteriological goal, to benefit oneself and others. So this is a quote from Chatushatak by R.A. Dev. He is saying that Asmin alpa punyasya sandehopi na jayati and bhava sandeh matrena jayati jarjarikrita. Actually what he is trying to say that this, when you explore the reality, the bhava, the phenomenal world, if you start questioning it, it's jayati, it will shatter the whole samsara into pieces. You can read the translation. And more importantly, he is saying that only those who have less merit, alpa punya, जिनमें अल्प पुण्य है, उनको संदेह नहीं होगा. But those who are punya, those who are more meritorious people, they'll always question this reality. And through this inquiry only, we can the emancipation or nirvana or that can be achieved. So this is there is immense importance of true reasoning and inquiry of reality within the Buddhist system. Now what I'm going to present here, just I haven't been a student of physics as such, so you may find some parallels between what physicists are saying and what Buddhist philosophy explores about the reality. So if you see here the jarjari, the shattering of samsara, this one you can relate it to somewhat what is called decoherence. So decoherence, basically what when observer or this instrument is introduced to a quantum state, then when you find the exact position of that particle there, this wave function collapses, and there are innumerable probabilities to find that particle. But why a particular position is found? So this is the question which has yet to be solved. Or, for example, in Schrodinger's cat, whether the cat will be alive or dead, or 90% dead, or 70%, there are innumerable possibilities. But what makes that cat, when the observer is looking at the cat, what makes that cat to be in that state, that particular state, that fixed state, what physicists call the transition from quantum state to mechanical state. So here, this is a quote from Moola Madhyamik Karika, and here R.A. Nagarjuna. This earlier I mentioned the quote. It was from R.A. Dev. He came from all the way to Sri Lanka to study from R.A. Nagarjuna was his guru. Around 1st, 2nd century AD, they were existent. So Nagarjuna is saying, Karma Klesha Shayan Moksha. I'm just reading the Sanskrit verses so that original thoughts were written and in these languages. So just as a respect to those great masters. So he's saying Karma Klesha Shayan Moksha, Karma Klesha Vikalpata. This Vikalp term is very important. And then he's saying Te Prapanchat Prapanchastu Shunyatayam Nirujyate. These two words Vikalp. V is a prefix and Kalpa means something kalpana, to imagination, thought constructs. And V is something Vishesh, something special. So special thought constructs that results into prapanch. Panch is 5, panch, and pra is again upasarga prefix there. So these 5 senses, they make this all elaborations, and that is generated through vikalp, special thought constructs that is creating this epistemological reality. Now this thought construct, there is this is direct from the sutra. It is Upali Paripreksha Sutra. Upali was a barber of Buddha, and he also became the first Vinaya, the first holder of the Vinaya Pitak. So these in ancient India, these discussions were very much existent, not just amongst the philosopher or special ones or professors, but also the commoners. So Upali asked a question, and then Buddha is saying, the various delightful flower blossom and sparkling supreme golden abode stand alluringly. There is no creator. They are posited by the power of thoughts. Through the power of conceptualization, the word is imputed. So what the word you are seeing, it's all through power of conceptualization. We just said vikalp. So that is what is being projected there. And later on, scholars like philosophers like Arjuna and they all developed this theory based on that. Here Arjuna is saying that since there is no phenomena which is not dependently originated, now this dependent origination, this is a very profound word and has very nuances I'll just discuss. So he's saying whatever phenomena, whether it's a subjective or objective phenomena we are seeing, it's all dependently originated. So this word is pratyatya samutpad in Sanskrit. This dependent origination. Now this comes, I'm just giving you some etymological meaning of this, and I suppose many of us are aware of little Hindi and Sanskrit. So it's a prati. Prati is there is term pratyaksh, prati aksh, matlab aankh ke samne, aksh prati. So prati means something in front, and tya is a pratyaya which makes something into motion. So pratya and sam together, samvai, sammelan. So all these sum means together, and utpad. So just in morning session, Professor Goswami was mentioning about this utpad word, which he translated as a production, which is very appropriate translation. But utpad also has a further etymological ut and pat. So ut means something produced, and pat means girna, patan. So something produced and vanished. So there is a Pali saying upajitva nirlichanti. The moment it is produced, it is disintegrated. So this utpad, this is explained by Bhavi Vivekananda, another Nalanda master. So what pratyatya samutpad, this is the one of the fundamental concepts on which the whole Buddhist philosophy or whole Buddhist thought process has been developed. So pratyatya samutpad, from etymological derivation, you can see the interdependent production set into constant motion. So all phenomena, whatever, if it is dependently originated, it is something interdependent and constant in motion, especially when two subject and object, the phenomenal reality and the epistemological and ontological reality, when they are in combination, this interaction is happening, and through that things are producing and also some utpat. So the moment it is being produced, it is also being disintegrated. So this is generally it is translated as a dependent origination, but I'm not so happy with this translation, because origination has a connotation of absolutism, which is not accepted in all Buddhist system. So interdependent production, something like that, which is translated as dependent origin. And what I discuss, this is from the Prasanna Pad, a commentary on Mula Madhyamika, the Acharya Chandrakirti of 7th century Nalanda master. he discusses this in his text. So this is the Sanskrit version which I gave just a summary. Now the same Acharya Chandrakirti in another text called Madhyamaka Avatar. He is giving the region of creation of the whole phenomenal world. So he's saying Sattvam Lokam Bhajanam Lokam. Bhajan means something patra, the container. And Sattva is a sentient being. So the loop of a sentient being and is a container word. So what it's a species specific word. It's not something the way human being we have a certain limitation because of sense organ. So the reality which we see, it's a species specific. For example, butterfly could see more colors than us, and we cannot imagine the colors beyond that. But there are species, so we live in a species specific world. So this species specific word is container word. So it's a container. What it means that there is externality. It's not something the way. And the mind is that creates this utter drawing. So there is a kind of utter chittam eva rachete ati chitram. Karmajam, so now he is giving this. So the karma produces the phenomenal world. And when the karmic mind is vanished, there is neither karma nor the world. So here what is explaining that interdependence of this subjective and objective phenomena, and the basis of which the karmic propensities. So another the continuation of that same verse. Although matter exists and it has no intrinsic status like that of mind as an agent, it is any other agent besides the mind that is negated. So besides mind, any other agent, whether it's a material, the prakriti, or whether it's a god, all things are negated beside the mind. And it is not the case. So the production of matter is posited to be the mind. So this is the verse number 70 is saying. And he's giving another example for this, as he mentioned this species specific word. So one of the sutras, of course it's debatable, but one of the, not sutra, actually it's a Samaya written by R.A. Maitre. So it says that species like a ghost being, they don't see the water as a water, they see as a flow stream of a past. And so, and devas and devis and godly beings, they see it as a nectar. So all these are species specific. So from objective side, there is no ontological status of the reality, but it is the karmic propensity which is causing that sort of manifestation. And he is also saying that grahyam vinana grahakata vyuktam. So without the grahak, the perceiver, and there is no the grahya, the objective reality. So again, the interdependency is there. And now, apart from Sutra and Shastra, the original saying of Buddha and further commentaries, in Tantra also this concept comes. Generally it is believed that the Tantra only it's about Mambo Jumbo Vishwasi thing. But this is a direct Tantra, not an explanatory or any commentary. Hevajra Tantra has this. It says Srikaram Advaya Jnanam, Hekaram Yetpadishunita, Rukaram Apatavyun. So actually there is a tantric deity with 4 faces. So all these 4 faces represent Sri, He, Rupa, 4 faces. And the Sri is non-dual gnosis. So objective and subjective duality that combined together is Sri. He is the causal emptiness of phenomena. And the mind produces the all phenomena, which is being posited. Ru is the conceptual web that separates the notion of self. And Ka is the absence of subjective-objective dissonance. So this is from the Tantra, Buddhist Tantra, Hevajra Tantra. So it's also the continuation of that same Pratitya Samutpad. So Pratitya Samutpad, that means Sarva Dharma Shunyata, emptiness of all phenomena, absence of any intrinsicality in that phenomena. So which means there is no self. no intrinsic self as such. And this concept, when especially in Mahayana, when this concept was developed, there was tremendous shift in the shift in the approach. And Nagarjuna, he something very revolutionary statement he makes in Bole Madhyamik Karika, where he says that the nirvana se yakoti sa koti samsarana. What is the category of nirvana is the category of samsara. So he's equating the nirvana and samsara. There is not even a finest gap to be found between the two. So ontological reality itself, the pre-created reality, that itself becomes, if you see the absence of subjective objective dissonance, so that itself becomes the nirvana category. So this is something very unique and not so easily comprehensible amongst Buddhist schools also. But what his meaning is there. Yes, I'm concluding. That this is from Bodhisattva Shantideva, he is another Madhyamika follower, comes into around 8th century from Nalanda. He is saying that Sattva Chetram Jinam Chetram. So the samsara and nirvana, so the Sattva Chetra, the samsara, the sentient beings realm, and Jina Chetra, the field of Buddha or nirvana, they both are same. Sattva Chetram Jinam Chetram. And Ityena Munina Uditam, that Muni is the term for Buddha. So this was said by Buddha, he is putting some sutra there. And then Etena Aradhyena. So by worshipping of just the sentient being, Sattva Chetra, Bahva Paramogata, many have transcended and achieved nirvana. So what it is that this reality what we are seeing, it's just extension of our own. I remember Professor Christopher Fuchs, one of the top quantum physicists. I had a very good interaction with him, and he showed that the quantum physicists, the apparatus and the thing which they are operating, they all start merging. The observer and the observed reality. So something you can find. I found some parallels that this Sattva Chetra and Jina Chetra, they both have no dissonance between subject and object. So this gives immense importance to have a respect for the sentient world, the conventional reality, because the reality which I see, or if I harm someone, or if I harm environment itself, it's not the objective or something separate from me which is I'm doing some harm. It's extension of my own being. So that is what it is. So therefore, this is the concluding slide. So therefore, this is concluding in concluding chapter of Bodhicharya Avatar Bodhisattva Shanti. He says that this is an aspiration, Bodhisattva Vow aspiration, that for as long as space endures, for as long as sentient being remain, until then may I do remain to dispel the miseries of the world. Thank you.
Very much, Pranshu. Some of the time has been taken by the transition period from one speaker to another speaker, but we will have maybe 2 or 3 questions, and then we can continue our discussion. I'm very sure the speakers will be available in that time. So, any questions? Yeah.
Yeah, well, I choose the topic decoherence. I have the following question in my mind. The question is that there are 2 levels of reality to consider. There is quantum reality and classical reality. And physicists are trying to get a logical way from one reality to others. So our question is there any that kind of logical procedure exists in philosophy, even in Buddhist philosophy?
This question start.
Yeah.
So when seen from a physicist perspective, a Buddhist philosopher would say that when this coming to decoherence, the transition which is happening from quantum state to classical state, the specific state of that particular classical state of reality, observed reality, is coming because of the karmic propensities of from the observer.
But what is karmic propensity?
The role consciousness which is playing a role in a form of karmic propensity to create that reality. So in a way, it's a consciousness.
No, but you know, in physics, when you say equivalence or correspondence principle, we don't use consciousness as such.
Yes.
In formalism, nobody has been able to include how consciousness or attention can be included in the equation.
Precisely.
Or is there any scope in quantum theory which can encompass these things?
Precisely. So that is why there is no such final theory in quantum physics.
Not final theory. I am asking whether there is a logical procedure which can be understood. Final theory, you or me cannot say that this is final theory.
Yes. So what I mean to say that this is where I don't say that okay, this is the Buddhist philosophy would answer solve this quantum problem.
We are not asking whether there exists any logical procedure.
It's their own procedure, own system of logic and debate through which it has been explored.
Okay, maybe you can. And one more question to Dr. Ravi Prakash. I can tell you the way you are presenting Penrose and Haveroff, those kind of things, that is totally discarded for the very simple reason. The reason is that when stimulus falls on my retina, after that there is no wave function. The millions of receptors in the retina will be activated, and the ions will be propagated through actions coming to central nervous system. So there is no questions of wave there. So wave superposition is a misleading term. That's why the framework is already severe.
Yes, it's correct. Basically, the experiment by Radin et al. In 2013, they were trying to see if at the level of the perception of the light, okay, that you are observing at the level of the retina, can the consciousness be localized at the level of retina for perception of the light as a quantum phenomenon?
Radin's experiment was not able to.
Yes,
It was not repeatable.
Yes,
Severe degree.
yes.
First in there. These will be the only two questions.
No, sir, I have one.
Okay, first. Yeah, yes.
My question is directed to Professor Usha Devi and Dr. Ravi Prakash. It is a very simple question, and I have been waiting for a long time for a forum like this to ask this question to the people I consider to be the right people to ask. Is there life after death?
I would like to answer that. I say yes. Okay, because I have conducted 3 studies on near-death experiences, and out of the 3 studies, especially the studies which were related to drowning states, where the brain was still active and the heart was, it was just functioning at the terminal level, and they were revived from that state. Okay, and that is one part. And the other studies which were conducted on coma, who were like in indefinite level, they have been coma. And we were not able to find out whether they will come out of the coma or not. But they came out after, say, we kept a duration of 45 days to say that the coma was significant. Okay, 45 days is very long in neurosciences. Very rarely people go to that much level. But in my study, and my Chinese and Indonesian collaborators, they kept a duration of 45 days. And we found that the brain dead state was almost declared for them. Okay, but they came out and they were able to say things which temporarily we may not be able to say that whether it was after the brain dead state or before the brain dead state. But they were able to say things which were difficult to accept or believe that they would not have observed. So what I mean to say is that brain is dead, but the consciousness is still alive. Okay. So I say that in the way that people say that life after death, second birth, third birth, maybe not like that. Okay. But beyond the death of the body, there is an element of consciousness that I am pretty sure as of now. But I was not sure earlier. But now I would say that we have enough data to say that. And similarly, other people who have conducted study on near-death experiences, they have also said that there are high chances that even after the physical system stops working, the consciousness stays alive. And not only because many people have put up the idea that it is just the neural networks functioning apparently that creates the image of light and all. It's not about that. It's about the subjective experience that they experience at that point of time. Okay, see, suppose I put a lot of noise, you will not be able to make a sense of it. But you making a sense, that is consciousness, right? You are able to integrate all the information into your subjective state. That is the consciousness that we are talking about. And they were able to do that. That is why it is very difficult to say that there is nothing after brain death. So that is my take. Yes.
You would right away say that in physics we have an approach where controlled experiments will tell us what to expect and how to go about. So in that sense, I would say observation or measurement itself is designed such that I can read and I will control. So for example, the non-linear stochastic equation that I was talking about, there are two different measurements for clarity, homodyne and heterodyne. Each one will give you a different trajectory. That means observation, which way you do is one thing, and then post-grained, average it out, you will get the same behavior as what is master equation. By that, what I mean is, do we have a way of observing things in which can be done, is what we say. Beyond that, I will not be able to say anything. Thank you.
Thank you, ma'am.
Sir, I have
I'm
one.
so sorry that we have already moved into the lunchtime by 10 minutes, and lunchtime itself is very limited. Why don't you ask your question during lunch? I'm so sorry, I really apologize. I would like to thank these three speakers on behalf of you, and I'm also very grateful to you for your attention. Thank you so much.
Thank you. Thank you for the very enlightening presentation. And thank you for the very enlightening session. And I would like to request Professor Mukunda to facilitate our chairperson and the speakers with the salt. Professor Farrell. Professor Usha Devi. Dr. Ravi Prakash. Mr. Francis Santosh. Thank you, Professor Mukunda. Now we shall now break for the lunch, and lunch has been served at the left side of the hall, and the second session will start at 1:30. Thank you.